Hello, everyone. It's Abir. Welcome with us in the third day of DevFest 2022 talks held by GDG Algiers and Women Tech Maker. Today, we have three special talks about in several domains. We will have at first a talk about guide to building Flutter app ready to scale by Mr. Raouf Rahiche. The second talk will be held by Butushint Akram. It's about demystifying Kubernetes, understanding the details. And the last one will be a talk about you are loading images wrong in React with Mr. Islam Maboud. Now, I'm going to let you with Lamia to introduce the first talk for you.
Thank you, Abir. Good evening, everyone. This is Lamia Ben Salem again, computer science student from Algeria. It has become a regular aspect and part of the DG Algiers community and WTM to update ourselves according to the growing demand in the computer science field. Therefore, we are gathered today, here, now, launching the third talk among a series of 10 talks, the first activity of this year's edition of DevFest. On this auspicious occasion, it's such a proud privilege for us today to have Mr. Raouf Rahiche, a Google developer expert for Flutter and Dart, who will enlighten our knowledge about Flutter with his talk titled Guide to Building Flutter App ready to scale. So we can't be more thankful, Mr. Raouf, for joining us. Now we'd like to hear more from you.
Thank you so much, Lemi, for the introduction. Assalamu alaikum, everyone. My name is Raouf, and today we'll be talking about a guide to building Flutter apps ready to scale. Just double checking that my slides are showing up and everything is okay. Okay. Cool. So yeah, let's just get straight into it. What's the goal of today? And to understand that, we will need to construct the title of this talk today. It's obviously a guide, but it's by no means a definitive guide, meaning I'm not going to talk about every possible situation or every possible problem and challenge and every possible solution. I don't even think, even in a perfect world, that there is a guide, there is such a guide where all the possible scenarios are explained. So this is going to be a very, very opinionated guide based on my experience. And the second part is about building Flutter apps. And that's where I think the excitement is coming from. I'm also going to be very specific about Flutter, since Flutter now supports multiple platforms. I'm going to be just talking specifically about Android and iOS, and I will try to ignore the web or desktop versions or flavors of that. And ready to scale is the part that I will be going deeper into it just in a second. But most importantly, what this talk is about is a couple of challenges that I have had during my experience with writing Flutter applications, and things that I wish I knew on the first day before hitting the deploy button of my applications. And hopefully one of these is gonna be helpful to you and will save you a couple of hours or a couple of days at some point. So 5 years. 5 years is actually then the duration I have been writing Flutter code. So since end of 2017, I saw a talk by Google developers showing Flutter, and since then I have been writing Flutter code on a daily basis for multiple clients. This is the list of clients I have worked with directly or indirectly. Hopefully you will be able to recognize some of them. Some of them are like local brands here in Algeria. Some of them are very popular as well outside. But this is the range of products that I have worked in, or the environments, either just a simple one-to-one freelance business where just someone comes to me and they ask me to build their application, to corporate or even a corporate that is considered the biggest in a country, to startups that are either bootstrapped, meaning that they made their money and they are able to grow just by making money, or profitable businesses in the same scale, or even startups that are backed by millions of dollars and have no products yet. So what I'm trying to say here is that I have been running like my career as a startup just in order to gain as much knowledge as possible, having to choose in one path and stick with it for a long period, and I tried just to get the knowledge from all of these possible scenarios so I can have a better knowledge of how to build better and more scalable Flutter applications. So on that, let's now talk about scalability or scalability in general. Well, it's just from the name of it, we cannot have a definitive answer to that. But one, it's really not just a number. Like I cannot set a number and say that after this number you are in the scale phase, and before this number you are like a small number. So it's definitely not a number. There is no clear line, but the definition or the general definition is that at scale typically refers to handling larger volumes. So just based on where you are right now and where you want to go, if it is larger numbers than what you currently have by order of magnitude, or even by 2x, 1x, or whatever, you are scaling. So scaling can be you can organize it in many different ways. This is the way I came up with it for the purpose of this talk. It's either about people, code, or content. Let's talk first of all about the easiest and simplest one, which is people. The common scenario is that you add more people or more developers to developer faster. And if we take this into theory for a second, if we have a list of features to implement in one application, let's say, for example, 100 features, and we have a developer who have been able to make one feature per day, we know that it's going to definitely take longer than 100 days. But let's just be in a perfect world and say that they will spend 100 days to develop all of these features. The first thing that comes to mind is that adding another developer means that we will deliver the project in half the time, and we will do it in 50 days instead of 100. I mean, it might work, yeah, but that's where adding more people, and that's where the scalability problems shows up, because there is no way or any chance that if you add 100 developers, you will be able to finish the project within 1 day. It's like impossible. Like that's the type of problems that we will be talking about more importantly here today. Is the challenges that come when you add more people or more code or more content, and how we can handle those. So the first one, or the first kind of scalability is in terms of people. The second one is more code. You can do this alone, like you can have your side project or you have your main project, whatever it is, you write code, you add more feature. Every time you add more feature, meaning you add more complexity and more code to it. And as a human, you won't be able to, even if you work on this project every day, you're still working on different parts of the project. So you will always have to come back to a previous part to maintain it, or add something totally new on top of something else. You won't be able to reason about all the moving parts of the project at one point, and moving will always get slower as much when the project grows. So this is the second type. When we are organizing the types of scalability. The third one is content. And content is a bit more abstract, but the way I see it is that obviously there are types of content. Simply the starting one is text, images is necessary, audio, video, must, 3D objects, and the list goes on. But the problem is when we have dynamic content and we serve it, for example, in social applications, the content is streamed from multiple places, and it is very hard to have an environment or infrastructure that looks similar to what the users are having, or even in terms of content, using applications with all of these types of rich content, such as 3D object or maps or videos or anything that can be considered expensive to render, is not going to be the same if you run it on a different device. So these types of problems comes where you add more content, or you need to handle more content, or more elements on what you are displaying on that small screen, since all of this talk is constrained by the fact that we are targeting mobile devices. So those are the scalability issues, or the scalability main issues. But now let's talk deeper into the details. Pretty much each one of these single challenges that I will be describing here can relate to one or two of these problems at the same time. So first of all, let's start by the mother of all of our problems as mobile developers. If we are going anywhere to target many users, we need to go through the gatekeepers, which are App Store from Apple or Play Store from Google. And these two make it very, very hard for us as developers to revert changes or make fixes. So traditionally, backend developers, if they have a problem, they go fix it, they push the fix immediately, it's out there. Same for web developers. Most of the time, if they have a problem, they fix it, they push the fix, and it's available for everyone as the latest snapshot. For mobile apps, it's a totally different story, because we have to go through the App Store. The App Store needs to take its time in order to approve our app release. So there is no way it can be immediate. The best chance you can get is if you do expedited reviews, and you are in the best luck, you can get that within a few hours. So if it is very urgent, you just wish that the feature didn't exist. So the App Store Play Store problem here introduces a couple of challenges to us, but most important is that we always know that whatever we are pushing right now, we have to ask ourselves with the teammates, are we ready to commit to this? Are we ready to push this? Do we know 100% sure that this is safe? So the quality bar is different from other types of applications, such as the web or the server ones in the backend, for example. So that's the first one. Second one is that Flutter specific. Flutter does not support something called code push. Other know it as hot update or out of band updates. These are very common with hybrid technologies such as Ionic or even React Native, which is not completely hybrid, but is similar also to Flutter in terms of the quality of the apps that they produce. But they do also have the option of doing hot updates or code push as well, which is a feature where you can send your app through the app review and then send a completely different version of your app just through the internet, through some other middleware provider. So if there is a problem, you still have the possibility of doing that only on the fly without having to go through the App Store, Play Store. It exposes a security vulnerability. App Store and Play Store are trying to prevent that somehow, trying to make it a bit harder for anyone to be able to do such an application, but still a lot of people prefer it, and for some businesses it is necessary and they cannot live without it. The solutions to some of these problems, the solutions that I have seen throughout my work with other companies, is that if we know that this problem is going to happen, and it will happen, there are some times where we wish we did this little thing on the back end instead of doing it on the client side. Now, the problem here comes is if we do something like a logical operation on the client side, is obviously going to be so much faster. It's going to be offline, and it will be so much consistent, and we can rely on it all the time if we do it on the client side. If we do it on the backend, we obviously have to require connectivity to do that action, and it will take delay. It will be slower because of the delays. So we try to not do that. But there are some certain actions, for example, where it's very clear and easy one. For example, if we are using Firestore, for example, for storing the data, and we have an operation where we do multiple writes to multiple collections, that's something we cannot do in one operation. If we do it on the client side, we earn a couple of features, such as being able to do it even though we are offline, and then Firestore will try to do it when to continue the operation when we are back online. But this is one of the sample situation where, if it is possible, whenever it is possible to do this on the backend, we always try to delegate that work and do it on the backend. So that way, we have at least one more important part of our infrastructure or our application in the backend. So if something bad happens, we know that we can change that, and we don't have to send a new application push. That's like a very, very common solution that you can see between different teams around this problem here in Flutter. Another solution is RFW, which is Remote Flutter Widgets. It's a package by Hixie, who's the lead for the Flutter team. This package is trying to help with the idea of having remote updates, but it is probably just UI only, because the way it works is it tries to parses the code that you have as a widget tree. That's why it's called Remote Flutter Widget. It's specifically for Flutter widgets, not entirely for writing your logic or completely switching the application. And it is very it's not very abstract. It is very raw. You can have mistakes very easily. It's a solution that you can use in places where you are not exactly sure what you want to show there, but you are sure of one thing, which is the fact that you will need to update it at some point, and you just don't know what to update it to. So that's the time where you can rely on using Remote Flutter Widget package and be able to drive the UI completely from the backend. Let me just remind you again, this is no way where you can just completely write your application in a string and try to push it. It's going to be very, very unmaintainable, and it probably will stop around just a couple of widget, and it will start to become almost impossible to handle and to reason about. This is probably the very first challenge that you will see. The second one is about crashes. One thing for sure and for certain is that your app will crash at some point. There is no app that is 100% crash free. And you can't and you really don't want to rely on users to figure out what's wrong with your app. You don't just want to push application to the App Store, Play Store, and you thinking that if there is a problem with my app, people will just tell me. People won't tell you. People will just give you 1 star and tell you bad. That's all you're going to get from users. So you have to keep in mind that that's not the way of handling app crashes. And the right way is obviously using crash reporting tool. There are a couple of them: Crashlytics, Sentry, Backsnap, and Instapack. A lot of them. If you go to PubDev, you will find a lot of them. I usually use Crashlytics and Sentry. These are the most common. And if you use Google Cloud services or Firebase in general, Crashlytics is going to be a very good integration with the other services to give you more insights around what happens in your crash. And speaking of that, the one thing that you always will sure want to do when using any of these packages is you want to set up this on the first day. You want to set up a crash reporter that sends the raw data as much as possible, like whatever you have, like the app version, the app size, the whether the system is in dark mode or white mode, whatever it is, like all the possible raw data that you think is going to be helpful to you, you can add it. But it's not a progressive operation where you just say, I will just add the necessary. I will try to be optimistic about this one and just send the default data. And once I need the new data, I will try to add it and see what happens. I'm pretty sure that if you are at that situation, you're already late, and then you have no idea what's going on, and you just keep going and trying to add more and more raw data. So the idea here is just add as much raw data as possible. Some of these tools, just make sure based on the tool, like some of these tools, they already sent so much raw data with them as well. But it's up to you in the end which one do you choose. So you also double check what they are sending, and if there is something you think is going to be important for you to debug your app crashes later, make sure to send that from day one. That's about app crashes. Now let's talk about navigation. The problem with it in general in mobile is that there is no standard for cross-platform navigation. Maybe there is a standard for Android 9. It's a different one from Android 10. It's a different one from Android 12. It's definitely a different one from iOS 6. All of these versions have different navigation standards or ways of navigation, even animations. So cross-platform tools such as Flutter tries to be very, very platform agnostic most of the time, and that's even what we try to do. Like if we are trying to do a custom design, we always aim to do something that doesn't have to actually be 100% exactly looking like the platform. We don't want to be just another Android app or just another iOS app, but we want to stick with their standards as well. Like, for example, the fact that users can swipe back to go to the previous pages that are very common for iOS users and lately with Android users as well. So we have to keep those in mind as well. And other problem for navigation is deep links, since they are one of the most important tools for marketing. Marketing people are probably people that you really don't want to hear from a lot, but if you really want to speak with them all the time, you just break your deep links and make sure that they are not taking them to the right place, and that's how you're gonna get the marketing lesson from those people. But the solutions are generally about documenting and communication here. There isn't a silver bullet or technical solution for all of these problems. The solutions that I have seen so far are about like documenting all possible navigation scenarios. So it's easier for me and for other developers to reason about. And one thing to be clear about here, I'm not talking about like writing a document that have every possible navigation scenario, as in like if I click here it will show this one. Let's write a scenario like the different situations where, like for example, if you have an app and if you have an app where you can let the users do certain actions before requiring them to authenticate, and then at some point they need to authenticate or log in or do whatever it is, you have to show them that. So how do you handle that scenario? Do you redirect them to a completely new screen, or do you show it as an overlay? Those type of scenarios you just need to write down, like the critical ones, or the ones that seems like not very simple enough to reason about. Those are the ones that you have to have in a document. Otherwise, if you have a document that evolves everything or probably is even automated, it's just as useless as the code that you are writing. Because if you are ending up with an architecture or a diagram of all of these different scenarios, there is no way for you to reason about them. You cannot see the flow, you can only see the noise. So the best way is just to document the key scenarios. Obviously they still all the possible scenarios, but still the key ones, not just every possible situation. How do I do that? Usually is by creating an abstraction of the Flutter navigator and never going through navigator of context and never going to use that directly in my code. In that way, it can have only one file. Let's say it's called app navigator, where I have every possible navigation scenario. The common ones are in one section, and that way I can keep that very maintainable, and it's very easy for me, obviously, to reason about. And second of all, it will be very easy to refactor and maintain over the long term as well. So that's about navigation. Now let's talk about testing, since they are crucial to keep the initial speed of development. Let me elaborate a bit on that with the example that we had a couple of minutes ago about one developer and the complexity of code. For example, like we have 100 features, one developer developing one feature per day. The assumption that they will be able to implement all 100 features in 100 days doesn't come for free. Like, you have to assume that they are writing tests for all of these features. Otherwise, every time they make a new feature, there is no way for them to test everything that they have accumulated in the last, for example, 10 features, to make sure that they haven't broken some part of those features. So the only way to ensure that and have it in a way that is safe and keep the initial speed of development is by writing tests. But the problem here is that more tests will take longer to run, and thus will increase the time between creating PRs and getting merged. So it's taking the problem from one place to another one, because right now we have these tests that are taking so long to run, and we are relying on them before saying yes or no to this PR. The solutions are very common, like running fast tests first with each commit. For example, unit, widget test, integration test. These are the tests that run in a millisecond or less than that. They are very fast. Like, you can run hundreds and tens of thousands of these tests within just a couple of minutes. So they are very reliable and fast. And then we have to make sure that the end-to-end tests are non-blocking, meaning that the test that actually takes up most of the time, for example, one test taking 10 minutes, two tests taking 20 minutes. Like, if you have just a test suite of 10 tests, it will take you 2 hours of just waiting for end-to-end testing to do its work. So we need to make sure that these are non-blocking, especially in the phases where we need to, for example, merge a PR fast, or we have a couple of PRs to merge. And one way of ensuring that can happen safely is by making sure we run this periodically in the background, where we run these tests from time to time, or every time we merge into master, or every time we make a new release tag. So that's a better time of actually making the end-to-end test blocking, instead of making it blocking with each PR, because that's very much non-scalable. One other way of obviously making this a problem go away is by scaling out. And scaling out here meaning that adding more to the infrastructure. So if we have one device taking 1 hour to run one test, then having two devices will reduce the time by 2, right? Obviously, the problem with that is it's very expensive. Let's make sure we know that all the CI tools by default, they provide parallel and multi-testing. Like, it's not just you run it on one device. By default, it's one of the key features that they enable you for, like, up to 5 devices at the same time. But if it is up to 50, it's better. If it is up to 500, it's better, but it's more expensive. So if you have the right investment, and you actually need to, it's very critical for you to have the end-to-end tests as a blocking part of your infrastructure, then scaling out is one way of doing that. Now let's talk about offline support for a second, because it's required for mobile applications. And the problem with it, it's not binary choice. It's not whether your app works offline or not, whether if your app is offline, we block the user from using it. This is a problem because we have to make sure it works. It's very well integrated in a way that if some part of your application can work without internet connection, then let it work without connection. You don't have to require the usage of internet in some parts just because lazy, or just because you don't want to support all of these parts. So that's the problem with it. It's also not a data caching only. Like, the problem of online support is more than that. The solutions are generally about making implementing an up-level connectivity module. I'm pretty sure you have seen these in the very major apps, where, like, they show you a banner at the top telling you that, oh no, you just became offline, and then just like as a way of communicating that you probably cannot do a lot right now with the application because you're offline. Another way is just making a very nice and easy to use API for both the UI and the logic parts of your features or of your whole architecture, to make sure that you can easily at any point make decisions based on whether the user has active connectivity or not. Next one, my favorite, dependencies. So dependencies are also one of the reason you can go fast initially. So you're working on a new application, you can do, for example, you can deliver so much in the first week because you've used all of these packages to help you move fast. But the problem with dependencies are a couple. First one is that they can crash your application. They are not written by perfect human beings as well. Like, we're not saying that what you're writing is perfect, but that also doesn't mean that something is written by Facebook or by Google is also perfect. They also can crash your application. So adding a new one, you just have to think about it twice. It doesn't matter with the creator of that. They can be the cause of crashing your application. And why is that a problem? Because you can also crash your application by yourself. Problem is they are crashing it and it's not you, so you cannot fix it yourself. You need to have all the knowledge that they have. The only way for you to fix it is to go to them or try to fix it, and that's obviously going to take more time. More dependencies will make it harder to upgrade, add new ones. This relates to the very first introduction here I was giving about dependencies. This one is specific to version numbers. So let's say we have we added like dependency B, which require or depends by itself on dependency A, and then we add new dependency for our new feature. Let's call it dependency C, which also relies on dependency A. Now, dependency C and dependency B, both of them require different versions of dependency A, and that's where the conflict happens. We don't know which one to use. So at that point, we will have to either do dependency override, which cannot really go well if we do it all over the place, or we have to do a fork, which we need to maintain over the long term. So it's very easy to see. Like, this problem you will be able to see quickly. Like, it won't take you months to see this problem. And the next one is about minor updates. So by default, when using Flutter samples or any other Flutter code, it is advised that you use the arrow, like the hat arrow shape. In order, that arrow in pubspec means that if there is a change in the patch version, update automatically. So you can see the scenario where you're like, yeah, I just built a new version of my application. I haven't changed any of the dependencies, and my application is now behaving differently to the different version. What went wrong? So it might go wrong because minor updates, they are written also by humans, and it's something that you haven't done by yourself. Like, you haven't upgraded that by yourself. So the problem here is that if it is automated and it happens by default, it will try to get the latest version, and that latest version by mistake have a problem or a break and change. That will introduce the problem, and you will be able to see it. The last one about dependencies here is that especially in the Flutter universe, is most of the packages, they solve for the general cases. For example, I wanted to have a feature where I share on Twitter. Like, I have a post to share on Twitter. I just want to share a post on Twitter. Now I go, the most common packages are probably to share in general. So they solve the sharing problem where they introduce the Facebook SDK, the Instagram SDK, the Telegram SDK, all of these, because they try to be very general. That's what a package do. They try to be very general and solve for everyone so that they get more likes or get more usages or whatever it is the reason. So use that package, and now you have all of this code that's not tree shakeable, that's adding up to the size of your application, that's introducing new points of failure just because you wanted one single feature. So that's another problem with dependencies. Some of the solutions is something that you will end up with if you have a bigger team, is having a process or a checklist for adding new dependencies. I'm pretty sure you will end up at this at some point. It's not something that you can write at the beginning, but it is something that it will just evolve from the learning. Like items on this checklist is whether this this package is coming from like a good maintainer. For example, if it's coming from the Flutter team, we know it's going to be well maintained instead of someone who just wrote it as a commit and the last one was a year ago and they haven't updated since. Then it's like just a lost cause and we have to create the package ourselves instead. Like you can very easily create this checklist by having a couple of different criteria to add for dependencies. My favorite one is never add dependencies unless you must need them. That's my best checklist item. Look all the version numbers. This is just like a trick or a tip, you can call it, but it's something that I really try to follow as much as possible. And since the version number is composed of 3 numbers, mostly major dot minor dot patch, we have to look that version by saying specifically that that's the number I want, and I don't want you to do the heart-shaped arrow going up, arrow up, saying that you want to update the patch number if there is a new one. No, just wanted to look at 100%. I don't care about minor updates. I only care about the version that I have right now. That's about dependencies. Let's talk about app performance for a second now. The problem here is that app performance is very easy to the problems with app performance are very hard to see on the beginning. They won't show up unless you have much more data or much more sampling data or different devices. The whole idea here is that you won't see them until you hit the production. Most of the problems you won't be able to hit them unless you really don't want to ship. You want to test it on all the devices. You want to test it with all different kinds of possible input, with German and the Japanese, with all types of text, and you cannot do that because you won't be able to ship anything. So it is a very hard trade-off. You have to ship and then adjust based on that in order to see these types of problem. It's hard to introduce prod level data during the development phase as well. As I said, we always try to do sampling data that's close to the production, but production is not for us. It's handled by the users. Users can do whatever it is that they want, and there is no way for us to think about every possible situation that they will do. And some solutions to this problem is one that they have been doing for the last couple of years, is that your testing device should not be the source of truth about the app performance. If you are actually using the latest and the greatest iPhone to do your testing, you will always sleep really good at night, or knowing that your application is fast, because you have a device that is capable as 100 times as a rocket. So you really don't need to worry about performance if you're using those devices. But the trick here, or the tip that I can give you, is go home, work from your parents' home, and that way you can eventually from time to time borrow one of your your Android devices and use it for testing, so that you can see the real face of your application and how it's behaving on low-end devices. One other way that actually helps clear the noise with performance, because performance is sometimes very subjective. You also, for example, you don't want your application to work smoothly on very, very low-end devices. Like, you cannot have something that's perfect for everyone. That's a good trade-off to have for the business. But having isolated performance test is going to make it easier to clear the noise, so that you can do this on a more theoretical way, so that you have numbers. You can have those numbers. So instead of saying your app is suddenly slower, you can have the numbers and see that the complex parts of your widget tree haven't changed in terms of performance, and it's just a noise or a false negative from some other part. So that's one way of handling the performance problem. Another one is analytics. Analytics becomes a product where becomes a problem. Sorry, when you have a lot of teams like data science team, marketing team, design, product. All of these teams, they all use different tools to get different data insights. About you have only one application, and it's only the one thing. But all of them, they require to use different tools for their different business needs. So the data team probably will need to use this raw data. The data science team will probably need it in a raw tool, or a tool that actually has a very easy way of exporting or analyzing that data. The marketing team needs only the top high level about app installs, the sources of those app installs, and stuff like that. The problem here shows up very easily is that we are sending the data to multiple providers, and that's a very slow process. It's not very slow, but it is a slow if we are doing it every 2 seconds. If we are tracking every action that the user is doing, the user stop and the user scrolling, the user scroll back, the user clicks. Every time we do it, we send a request to all of these providers. That's going to be slow, and there needs to be a solution. Event naming can get very inconsistent, especially if you are getting the naming from all different teams. Like the marketing team needs this to be in a name, the data science team needs to be this name. The only way to have naming consistency is for that to come from down, not from the top, meaning coming from the developers. So some of the solutions here are using analytics aggregator such as Segment. It's another tool where it's just a top level analytics provider. It's also an analytics provider by itself, but the way it works is gets the data from your application. It sends it to Amplitude, to send it to Google Analytics, to send it to Mixpanel and all of the other providers. So it is just a nice tip to implement in your application if you use multiple providers. It's not eliminating all the native dependencies, by the way, but it's eliminating the number of actions or calls, HTTP calls that are happening when we're calculating in general. So it's a good thing, or a good optimization to have all the events in one place in order to make it easy to apply analysis for refactoring. I always end up having all of my analytics event in an enum. An enum is very easy to make sure that I have a nice abstraction, so that if I don't use stringly like 100%, there is no way to have like the analytics as a strings in all over the place. You will just run up like you're like in the Wild West in 2 seconds. You won't be able to know what's happening, where is this coming from, why is this name different from this one. So having all the analytics, all the possible analytics in one place and putting them in an enum, meaning that you have an abstraction that require the events to be just this type, and one of these, it requires that they have all the unique identifier that's different from the other one. That's just because it's an enum. You can have some unit tests on them, for example, to ensure that all the names of the events are less than, for example, 400 characters, because if you're sending to multiple providers, each one have different asks, so you need to truncate that to the baseline or to the minimum, so that you can be compliant with all of these providers, analytics providers. So I think that's about it for analytics. No, we have one more. It's just a nice tip, about adding widgets that can collect events automatically. So I add this widget called Analytics Reporter. It works with common cases, for example, scrolling with debouncing, so that I don't have to send events about scrolling each time the user has scrolled. I can use it for other scenarios, complicated scenarios that are common as well. But the point is, I just have a widget that tracks the event and send it straight away. So it's only one job, is doing one thing, which is tracking the event and sending it to the analytics provider. Oh, another one, app versions. Yeah. So the problem here with app version is that whenever you deploy a new version to the App Store, it's not available to everyone. I think we have touched on this topic a couple of times so far. It means that you're just adding another version onto the stack, and that means you're not just maintaining the current version or the latest version. You are also having to manage and maintain the older versions that other people are using. So what are some of the solutions to this problem? One is cut to the chase, just implement force upgrade, just like banking applications have a feature since day one. And by the way, this is not a negotiable feature. I think everyone should do this since day one. Like everyone writing their application right now, go make the force upgrade feature. You won't need to use it. Maybe you won't need to use it for a year, 2 years, but the day you will need it is the best day, because you know that you have that option, and you know that you can require all of your users to be on one version. So the only problem with force upgrade, it's even that it's not 100% effective if it doesn't if your app works offline. For example, if you let your users use your app while it's offline, it means force upgrade won't work all the time, because force upgrade is just calling the server or an endpoint or using some other package to say to check up what's the latest or the minimum supported version, and comparing it with the local one. If it is above or below, if it meets the criteria, then we can let them run it. If it doesn't, then we have to show them a screen telling them to upgrade. They click on it, it takes them to the App Store, and they won't be able to go over that screen unless they download the new version of the application. So that's a very common use case, the app banking application that they do because they want to be secure. But it's like any type of a blocking scenarios, obviously not a good user experience. So you need to have it there in your application just for the dark days, but you don't use it as a like for a consumer application. Just don't use it like every day. Like whenever you just want a new upgrade, you just force your users to use it. Sometimes they probably need to use the application and they don't have access to internet, for example. So it's a very nice feature to have, but just don't use it every 2 seconds. The next one is implementing a flexible feature flag system. The problem here is not about implementing the feature flags. It's about having the code that manages all of these features, because feature flags are a very nice way of deploying features. So instead of actually like you have a new feature, instead of deploying it to all the people and then getting the feedback, probably it's buggy, probably there are like problems that are very hard to revert, or probably it's not a viable product. For example, just like Twitter did last week with the Twitter Blue, they have seen that account increase, whatever it is, I think people were taking the accounts of others, so they decided to stop that feature. So you always need to have such a way of reverting back, even if it is deploying for a small portion of users or for all the users. You just need a nice switch where you can say enable this or disable this feature. Yes, this is a very nice feature to have, but the problem with it is you cannot do it all over the place. Like you cannot have it, for example, add button. Let's add button and not add a feature flag for that. Let's add a new table. Let's add a feature flag for that. It will be, your project will be just feature flag system management. Like every time you go to your code, you won't be able to see the noise. You will always see the feature flags. Everything depends on a flag. The flag depends on another one. So the problem here, or this is a solution. Like I'm talking about the solution to the problem of app versions having feature flags as a system setup, but I'm also trying to introduce the other problem with feature flag is that it's going to be very noisy in your code base. So you just need to know when to use it, but have it so that you can do like system-wide testing, A/B testing. But the nice combination in a perfect world is having a force upgrade. Your application require internet, feature flags. So for example, you have a new feature and then you want just to test it on a couple of users. Yes, it worked on a couple of users, and then you release it to everyone. You require them to force upgrade. That way, if everyone is using the latest version and that feature is enabled, you can just feel free to go and remove the code related to that feature all over the place. If you are, for example, 100% sure that this feature is not going to leave the platform for the next 10 years or for the next 5 years. 10 years is a lot, but let's say at least for a year, like it's going to be there, it's going to be locked. So let's remove that code, let's remove all the noise and get the code base to the level where it was before so that we can ship faster. I think that's it for today. Thank you so much for attending my talk. If you have any questions, if we have any time left for the next 10 minutes, I guess we can answer all of that. Thank you.
We're actually so thankful, Mr. Raouf. Unfortunately, we don't really have enough time for questions, but we really appreciate your valuable time and your precious information. Thank you so much for joining us today.
Yeah, thank you so much.
Okay, thank you. So goodbye, everyone.